In the last few videos, we've been talking about the inverse derivative rule for finding the derivative of an inverse function. This isn't necessarily something that the AP is going to test you on specifically, but every once in a while they might throw a numerical question at you. So let's take a quick look at the IXL that I'm going to assign and get a sense of how you're going to tackle problems like this. All right, so here's the kind of problem that you're going to see. So the function f has the inverse function f to the -1 power, which we're going to read as f inverse. So if f of -3 is equal to 4 and f prime of -3 is equal to 2, so the value of the function at -3 is -4 and the derivative of the function -3 is equal to 2, what is the derivative of the inverse function applied at -4? So that looks like a whole lot. But let's take a look at how we can work this out on paper pretty easily. All right, so off to the document camera. So here we have the inverse derivative function, that the derivative of the inverse of a function is equal to 1 over the derivative of f applied at f inverse at x. And this is just the inverse derivative rule that we've seen up to this point, except that instead of saying g, I'm calling it f inverse. All right, and so that is what the rule is. And so what we're given for this problem is that f of -3 is -4 and f of -3 is equal to 2. And we want to find f inverse prime evaluated at -4. So here's the key idea, that we want to plug -4 in for x into this equation. So the derivative, remember that this prime notation is talking about the derivative just like this notation. F -1 evaluated at -4 is equal to 1 over f prime of f inverse of -4. And you might look at this and think, well, we don't know anything about f inverse. All we know is these functions right here. I'm sorry, this is a prime right there. That's my fault. Okay, but here's the idea. Remember that inverse functions just flip the input and output from the original. So if we know that given f, if the input is -3, then the output is -4, then f inverse just reverses that. So f inverse at -4 would be equal to what? Would be equal to -3. You just flip the input and the output when you're thinking about the inverse function. So now we can evaluate that. So that's 1 over f prime. F inverse of -4 is -3, and f prime of -3 is equal to 2. So the answer here is just 1/2. Okay, and so let's pop back to IXL and just guarantee that we get the right answer there. So we put in 1/2 as our answer, and you got it. Okay, so you'll see we've got tables here, we've got all kinds of information, but you're just going to take this information like you see here and substitute it into the formula in order to get your answer. And you'll see we haven't done a lot of talking about it, but around in that same area of IXL, you can see that you can have the same sort of problem where you could use the product rule or the quotient rule, where you don't know what the function is, but you just kind of have a table of values. And if you have problems like that, all you need to do is to use the product rule or the function rule or the chain rule or what have you, and just substitute in the appropriate numbers that you'll see there in the table, and you'll get that done. So I'm going to assign this one problem for the inverse derivative rule, but at least poke around with the others long enough to make sure that you would be comfortable with seeing other problems of this type, because they do come up from time to time.